So, lesson 5.5, solving multi-step equations and inequalities. So everything we've done with equations and inequalities up to this point are going to be included in this lesson. There is a procedure, though, that you go through to make sure you do these in the right order. The first thing that you always do is distributive property. Sometimes there'll be only one on one side. Sometimes there'll be one on both sides, and if you get a really long problem, you might have a couple on one side or the other. But make sure you do all of the distributives first. Then you go on the left side of the equal sign or inequality and combine any like terms you have there. Then you do the same thing on the right side. And then once you get to that point, you just get your variables together on one side like we did last week. Bring the variables together and then solve this two-step equation like we did a while ago. So distributive first, combine like terms on each side second, and then proceed to solve those equations, bring the variables together, and then get the variable alone. That's really what we want to do. So let's look at our first example. Each one of these I'm going to maybe add a thing or two as we go. But the first one is 5 times the quantity, h minus 2 equals 15. Is there anybody that wants to try this one? Okay, Dakota, so we have to do distributive first.
5 times h.
Okay, so we'll do this first, which is 5h
5 times -2 is
minus 10
equals 15.
equals 15. Okay, now you look for like terms on the left. Are there any? Nope, and then there's only one term on the right, so we don't have the like term step. Now we're just ready to solve a two-step equation. What will we do next, Dakota? Add 10 to both sides. Okay. What else comes down below the line?
5h
And
equals
5h equals 25.
You need to divide by 5 on each side.
Divide by 5.
Then h equals 5.
Okay. So that one you did very well. They've just added one step. That's the distributive property. That's the only difference from what we've done in the past. Any questions about that? All right, good job. Now I did one using it in inequality, so there's a greater than there. It's really no different. It's just when you come down, make sure you bring the inequality down each time instead of the equal sign. Who would like to do this one? Okay, Trayton.
8, 2 times x, 2x, and then 2 times -4 is -8, greater than 11.
Okay. Are there any like terms on the left?
No.
Nope, and there's only one term on the right. So again, we're kind of skipping that step. That's good. What do we do next, Trayton? Add 8.
Bring down the 2x, greater than 19.
Okay.
And then we divide by 2.
All right, this isn't going to come out evenly, so we're going to say x is greater than. You can leave it 19 halves if you want. Actually, you do that more in Algebra 1, where you leave improper fractions. We'd probably go ahead and change it to a mixed number. What would that be, do you know? How many full times does 2 go into 19? Do you know? 9, and what's left over?
7.
So 9, yeah. Let's go with 9.5. Okay, any questions about that? So again, that's just adding one step to what we're used to. All right, let's go on and see some where they add a little bit more. Okay, maybe I can get there. All right, so the next one is 6 times the quantity b minus 2 is greater than 2 times the quantity 2b plus 8. So this one, you'll see that there's a distributive on each side. So we'll need to work on that. Who wants to try this one? Somebody that hasn't gotten a ticket yet. Anybody want to do this one that hasn't gotten it? Stephen? Okay, Stephen, what are we going to do first?
First, you would take 6 times the quantity b minus 2.
Okay, so 6 times b is
6b. And 6 times negative 2 is negative 12.
right.
And then you would take the quantity, then you would take 2 times the quantity 2b plus 8.
Right.
Which 2 times 2b would equal 4b, and 2 times positive 8 would be positive 16.
Good. Okay, so we have 6b minus 12 greater than 4b plus 16. You look for like terms on the left and the right. Stephen, do you see any? Are there like terms on the left? So just the 6b and the negative 12, are those like terms?
No.
No. And then on the right, is there any over there? The 4b and the 16, are those like terms? No. So there's no combining of like terms yet. We haven't seen that. Now, Stephen, we need to bring our variables together. So which one is the smallest?
4b.
So how am I going to get 4b to go the other side?
You would divide 4 by both sides.
No, we've got 4b and it's positive and we want it to go to the other side.
Minus 4b on both sides.
Correct. Subtract 4b. Let's go left to right now. What's 6b minus 4b?
2b.
All right. What else am I going to bring down?
Negative 12. The greater than 9 and positive 16.
Good job. Okay, so our variables on the left. So now we're going to have to get the constants to go to the right. So what am I going to do there?
Plus 12 on both sides.
Good. So below the line, left to right, what am I going to have?
2b is greater than 28.
Good. And my last step?
Divide 2 by both sides.
Good. So b is greater than?
14.
Good job. B is greater than 14. Okay, so we did have a distributive on each side. There were no like terms. We're going to get to that eventually here, maybe the next one, to show you that step. And you just proceed with your two-step equation on these. Questions on that? So each time we're adding a little bit more. All right, let's look at this one. 3 times the quantity 4x minus 2 plus 15 equals 12x plus 9. Who wants to do this one? Okay, Tori, we need to do distributives first.
You take 3 times 4x and you get 12x. Then you take 3 times negative 2 and you get negative 6. And you write the rest of it down.
Okay, so we did our distributive. Now, on the left-hand side of the equal sign, are there any like terms, Tori?
Yeah.
Yeah. These two. So I'm going to have 12x, but I got to combine those two. So I've got negative 6. I'm in the whole 6, and I add 15. Where would I end up?
11.
Nope. I'm in the whole 6. Yeah, and I add 15. I would end up at 9. Okay, this looks a little suspicious, so this is something a little new. But once you get to this point, now you need to bring the variables together. Which one's the smallest, Tori? It doesn't matter. They're the same. So how would I make the 12x go away?
Subtract 12x.
Subtract 12x. Now, watch what happens here. This is something completely new, but this is something that you need to know for the I step. 12x, subtract 12x on each side. These two cancel out. Tori, what's left on the left?
Nothing. 9.
9 equals sign. 12x minus 12x falls out. And then what's left over there?
9.
All right. Now, this is extremely important to write down. If the variables fall out, like that just happened, we subtracted 12x from both sides, so there's no x term left. If the variables fall out and what's left is true, in other words, is 9 equal to 9?
Yeah.
Yeah, that's true. Then your answer is this right here. You literally write all real numbers. What it means is there is infinite solutions. In other words, any number that you can think of, you could plug into that equation for x, and it's going to work. All real numbers work. On your iStep standards, it's going to say infinite number of solutions. I can recall questions that were on the iStep and Acuity that gives you a list of equations and says how many of those have infinite solutions. And you have to solve every one of them and look where the variables fall out, but the numbers left are equal. Those are infinite solutions. Is everybody done writing the blue? Because I need to show you one more. And it's basically just the opposite of what we just did. So this last example, 7y minus 8 equals 3 times the quantity, 2y minus 4 plus y. So you follow the same procedure every time. I'm going to do distributive property. So the first one is 7y minus 8. On the right is my distributive property. So 3 times 2y is 6y. And 3 times negative 4 is negative 12. Plus I have another y hanging out there. So I've done my distributive. The next step on my list of steps is combine like terms on the left and the right. Well, on the left, 7y and 8, they aren't like, so there's none there. But on the right, I do have like terms. 6y and y. What is 6y plus y? 7y. So here's what I'm going to write. On the left, I'm going to put 7y minus 8. And on the right, I'm going to put 7y minus 12. Because 6y plus y, there's a 1 in front of this one. So 6y plus 1y, 7y. So do you see what's going to happen here? I need to now try to bring my variables together. In both cases, it's just as positive 7y. So when I go to subtract that thing, they're both going to fall out again. But this time, it's saying that negative 8 equals negative 12. Does negative 8 equal negative 12? That is definitely not equal. I'm putting a slash through there. That is false. So see what this thing says, if you can read it. If variables fall out and what's left is false, the answer is the 0 with the slash in it. It's called the empty set. When you answer these, you literally write the 0 and put a slash in it. And what that means is there is no number you could find that would work in that. Nothing works. Not one possible legitimate answer to that equation. So if the variables fall out and it's false, you put empty set. If the variables fall out and it's true, you have to write the words all real numbers. Are there any questions about that?